Here I am on YouTube once again, and the first thing that I get to point out is how antisocial social media truly is. I'm actually somewhat astonished by the amount of vitriol that a handful of people spew in the comment section because they disagree with what I have presented about the law of distribution and how PEMDAS doesn't even address it. Frankly, the responses have been of the type that I've only ever seen before in religious disagreements. And then it hit me. Fundamentally, it's based on a very similar structure of thought. What I mean by that is simple. You can find in the Bible that the group of people that Jesus had the most trouble with were the Pharisees. And what were the Pharisees really good at? Following the rules, especially the rules of the Bible and the rules they made up. They had them all down pat, and woe to you if you didn't obey those rules. But by being in that frame of mind, they missed the entire point of the rules. In the Bible, God didn't give people rules for the sake of rules. The rules were designed for the sake of people, to make sure that they weren't as evil to each other as they would otherwise be, and to give a path of reconciliation back to God. Now, mathematics isn't trying to get anyone right with God, but it does have its rules, and it does have its Pharisees, who know that rule book very well indeed, but who have no idea why the rules were put into place. All they know is the rule says you do this process and you aren't doing it. Therefore, you must be cast out into the darkness, you heathen. I'm sorry, I get carried away sometimes. But you can see this at work with the series of responses I did to Presh Talwalkar's solving of an equation. People who didn't have any understanding of mathematics are quick to yell that I need to take a first grade mathematics course again. Never mind that when I ask them how they can write out factorizations in their system, I never get a response. Nor how when I ask them how the law of distribution could even be handled in their system, there's just simply no response there either. It's almost like they don't know what the law of distribution is. So let me just wrap up a few things in this video. First, let me just focus on why it's such a bad idea to focus on PEMDAS, or the order of operations, instead of teaching students what the hell is actually going on in mathematics. So let's examine PEMDAS for a moment and see what we are supposed to do. The first thing is the P for parentheses. So we know when something is in parentheses, we solve all of that first before we do anything else. But we don't explain what does solving that mean. It just means if it occurs in there, you do that first. Next is E for exponents. That's pretty nice to have. Then we have M and D together for multiplication and division, and we end with A and S for addition and subtraction. Okay, that seems okay as far as it goes, but as I pointed out elsewhere, where do we do factorials or towers or trigonometric functions like sines and cosines? When do you do the absolute value of a number if that's involved in your equation? Is it at the start, or do you wait till the end to quantify the absolute value? And those are just the tip of the iceberg of things that PEMDAS never involves itself with. It never bothers to tell you when you do those orders of operations. Or how about the gem at the end? We're told that when we have multiple items at the same level of precedence, we do them from left to right. Really? So let me give you some examples really quick. So suppose you have 5 minus 3 plus 7 minus 4 plus 3. Those are all at the same level of precedence, so you solve that by going left to right. And what do you get? Well, 5 minus 3 is 2. 2 plus 7 is 9. 9 minus 4 is 5. And 5 plus 3 is 8. Great. Now, have you ever thought to yourself, what would happen if I ignored that rule that you must go left to right? And what if I was a rebel and did it right to left? What would I get? And remember, subtraction is just the addition of negative numbers, so we're really just adding things in a different order. What do you get? Well, we start with the end. You have 3 plus negative 4 is negative 1, and then you have that negative 1 plus 7 is 6, and 6 plus negative 3 is 3, and 3 plus 5 is 8. We get 8 again. That's the same answer going both directions. In fact, let's mix up the numbers. Same numbers, but let's sort them from smallest to largest. And now you get negative 4 plus negative 3 plus 3 plus 5 plus 7. You solve that, and what do you get? Well, negative 4 plus negative 3 is negative 7. Negative 7 plus 3 brings us back down to negative 4, or up to negative 4, I suppose. Negative 4 plus 5 gives us 1. And 1 plus 7 gives us 8. We're back to 8. Wait, so do you mean to tell me that you can do addition and subtraction in any order and still get the same answer? Yes! Mind-blowing, I know, but guess what? You can do that with multiplication too. What is 5 times 4 times 7 times 3? Well, you can do that as 5 times 4 equals 20, and 20 times 7 equals 140, and 140 times 3 is 420. Or you can do it as 5 times 3 equals 15, and 4 times 7 equals 28, and 28 times 15 is 420. Mix and match. It doesn't matter. Order doesn't matter at all. You can do addition, subtraction, and multiplication in any order, period. Any order you choose, as long as you're doing addition and subtraction together and multiplication by itself in the correct order of the level of PEMDAS. Within that level, you can do any order you want, because the only time that it matters whether you go left to right is with division. Were you ever told why division is different? Of course not. You were just told you have to do all the steps from left to right, despite the fact that I've just demonstrated for the majority of what's presented to you, you can do the same level order of operations in whichever order you feel like doing them. So clearly this rule that is in place, that you must do it in this order, period, is not explaining what is happening in mathematics. No, only division runs into the problem of order mattering, and that's because division is not communicative. The communicative law says that A plus B equals B plus A, and A times B equals B times A. Now, there are certain forms of mathematics, such as when you're using matrices, where multiplication is not communicative as well, but for elementary mathematics it is. But notice that in basic mathematics, division is not communicative. Why not? Well, you can simply plug it into that format. While it's true that A times B equals B times A, it is not true that A divided by B equals B divided by A. So you can't reverse the order like that. Consider when A equals 1 and B equals 2. A over B is 1/2, but B over A is 2 over 1, which is 2. There's another law of mathematics that comes into play here too. It's the associative law. That tells us that A plus parentheses B plus C end parentheses is the same as parentheses A plus B end parentheses plus C. And it also means that A times the quantity B times C end parentheses there is the same as parentheses A B end parentheses times C. The fact that addition is both communicative and associative is why you can do addition and therefore subtraction in any order you want and still get the same result. And the fact that multiplication is also associative and communicative for basic mathematics is why you can multiply in whatever order you want. It should come as no surprise to find out that division is not associative any more than it is communicative. If it were, then A over the quantity of B over C would equal the quantity A over B and quantity over C. But again, let's use a simple A equals 1, B equals 2, and C equals 3. The first, A over parentheses B over C end parentheses, is the same as 1 over parentheses 2 over 3 end parentheses. And if you remember your rules of fractions, when you divide a fraction by a fraction, you invert the second fraction and multiply them together across. In other words, replace 1 with 1 over 1, and then multiply that by 3 over 2, because you invert that fraction. When multiplying the fractions, you multiply the numerator by numerator and denominator by denominator, so you'll end up with 3 over 2, or 1.5. But what happens when you have the second quantity A over B end parentheses over C? Now we have a numerator with 1 over 2, and it's divided by 3. Again, 3 is really 3 over 1, so we flip that and we have 1 over 2 times 1 over 3, which is 1 over 6. Clearly, 1.5 is radically different from 1 over 6. So what does that mean when we look at PEMDAS? It means the real rule of PEMDAS should be that the order within a level of PEMDAS doesn't matter unless you are doing division. If and only if division is involved and you are doing the multiplication or division level of PEMDAS, you have to perform all the steps strictly from left to right. For every other basic math equation that does not contain division, it doesn't matter the order you do the steps within a level of PEMDAS. It only matters that the individual levels of PEMDAS itself are in the right order. In other words, you do have to do multiplication and division before you do addition and subtraction. This is something you would never know is even possible if you stuck with the rules of PEMDAS as taught by your teacher instead of understanding what is actually going on in mathematics, though. I would even be so bold as to wager that the vast majority of people who see this video have had PEMDAS or BODMAS drilled into them time after time after time, but you probably spent at most a single class on the commutative law, the distributive law, and the associative law, all in one class period. Each of those are actually necessary for you to understand what's happening in mathematics, and it's far more important for you to understand that than PEMDAS. PEMDAS is secondary because you can work out the rules of PEMDAS if you understand the fundamental laws of mathematics, since you will be able to work out which method preserves consistency and which methods result in contradictions if you know the fundamental laws. You will not be able to work out the fundamental laws of mathematics by examining the rules of PEMDAS, though. So, division is neither communicative nor associative. At this point, you might be tempted to say, well, it's probably not distributive either. But it is actually distributive. Yeah, another plot twist. Remember, dividing by a number, let's say x, is the same thing as multiplying by 1 over x. So when you divide by 2, you multiply by 1/2. That's the same thing. Now, what does that mean? It means that given the law of distribution, which is A quantity B plus C equals AB plus AC, it's true even if A is a fraction. So let's make A 1/5 and B 10 and C 15 for ease of calculation. What distribution would say is that B plus C over A is the same thing as B over A plus C over A, separated. Well, B plus C is the same as 10 plus 15, which gives us 25, and 25 over 5 is 5. Now, what do we get when we look at the other fractions? 10 over 5 equals 2, and 15 over 5 equals 3. So adding 10 over 5 plus 15 over 5 gives us 2 plus 3, or 5. It's the same answer. So yes, distribution is the same for multiplication and division, even though division is not associative, nor is it communicative. Because of this fact, commenters who have said that the factor that has been pulled out of the 60 divided by 5 parentheses 7 minus 5 end parentheses is really 60 divided by 5, they at least have not violated the rule of distribution in their arguments. Where their error comes in is in the fact that the divisor sign is the sign of the division operation and is therefore not the same thing as a fraction. Put it this way, in a fraction, you have an automatic grouping of every single value above the bar and every value below the bar, giving you the numerator and the denominator. There is no grouping of that type of manner when you have a divisor sign. So how do you handle the divisor sign? Well, you do that the same way you would all other operations of basic mathematics. In order to resolve an operation, you need an operand on the left and an operand on the right. The operation tells you how to combine those two operands to get your result. So when you solve an equation, you're simply reducing everything to the equality operation so that you have one operand is equal to another operand, and that is your final answer. You can have many operations, of course. What is 8 times 8 divided by 8 plus 8? And we can put that in the equation as 8 times 8 divided by 8 plus 8 equals x. So we have the equality in there as well. Normally we leave that off because it doesn't matter. I'll just throw that in here for consistency. Now, this is easy using PEMDAS. There are no parentheses, so we just do the multiplication, and because it's got division, we have to do the multiplication and division from left to right first. So we do that. 8 times 8 is 64. 64 divided by 8 is 8 again, and 8 plus 8 equals 16. But suppose I wanted to represent one of the 8's by a different way. Suppose on one of the 8's I factor a 2 out and get this. 8 times 8 divided by 8 plus 2 parentheses 4 end parentheses. And we say that equals x. And suppose that I further want to represent 4 in a different way, like this. 8 times 8 divided by 8 plus 2 open parentheses 1 plus 3 close parentheses equals x. Now, has that affected anything? Well, let's do it the way that proponents of PEMDAS would like for us to do it. First, we do the parentheses, and we get 8 times 8 divided by 8 plus 2 parentheses 4, end parentheses equals x. And now we do the multiplication and division, and we're doing them all together left to right, because it's all the same level of order here. And we get the following. We start 64 divided by 8 plus 2 parentheses 4 equals x. Now we have 8 plus 2 parentheses 4 equals x. And finally, we get 8 plus 8 equals x, which is 16. So that still works. We still have 16. What happens if we replace the very first 8 with that same structure that we're using here? Now we have 2 parentheses 1 plus 3 end parentheses times 8 divided by 8 plus 8 equals x. Again, we do the parentheses first. 2 parentheses 4 times 8 divided by 8 plus 8 equals x. That's the same as 8 times 8 when we do the multiplication up front, divided by 8 plus 8. Well, 8 times 8 divided by 8 plus 8 is the same thing that we solved at the very beginning. We've got back to our original one. We already know that equals 16. So that's all fine and dandy. And really quick, what happens if we represent the 8 before the divisor in this same way? Now we have 8 times 2 parentheses 1 plus 3 end parentheses divided by 8 plus 8 equals x. So again, parentheses first, and we get 8 times 2 parentheses 4 divided by 8 plus 8. And 8 times 2 is 16, times 4 is 64, and that gives us back to our regular 16. So again, this is all perfect. It's all fine and dandy. Dancing in rainbows with leprechauns. Well, we're not in Ireland, but whatever. Of course, I've left off the final one that everybody already knows. Let's replace the 8 that's after the divisor. So now we have 8 times 8 divided by 2 parentheses 1 plus 3 end parentheses plus 8 equals x. What does that give us in the world of PEMDAS? Well, again, start with the parentheses. So we get 8 times 8 divided by 2 parentheses 4 end parentheses plus 8 equals x. And then we start our multiplication. We'll start with 64 divided by 2 parentheses 4 end parentheses plus 8 equals x. But now we have to do 64 divided by 2. So we end up with 32 times 4 plus 8 equals x. That's 128 plus 8, and x now equals 136. It's no longer 16. It's now 136. Note that every single time we use the exact same way of formatting 8, and it worked for all of the operations except when it immediately followed the divisor sign. In no place did it need parentheses added to that structure anywhere else. In PEMDAS, it worked until division broke it. Now, you might be thinking, well, we just know that there's something weird with division. But what happens when we do the exact same process, except instead of using the rules of PEMDAS, we do the law of distribution first? Let's begin with that first example again. We started with 8 times 8 divided by 8 plus 2 parentheses 1 plus 3 end parentheses equals x. So first we distribute the 2 through the addition of the 1 and 3. That starts by making the 2 into 1 plus 3 into 2 plus 6 as a quantity. So we have 8 times 8 divided by 8 plus 2 plus 6, which is 8. That gives us our 16. Again, 8 times 8 divided by 8 plus 8 equals 16. Okay, so let's start off with the alternate version of 8. We get 2 parentheses 1 plus 3 end parentheses times 8 divided by 8 plus 8 equals x. Again, you distribute the 2 through the addition of the 1 and the 3 first. So that gives us 2 plus 6. And that 2 plus 6 becomes 8. And we get 8 times 8 divided by 8 plus 8 equals x again, which will give us that 16. We put it before the divisor. 8 times 2 parentheses 1 plus 3 end parentheses divided by 8 plus 8 becomes 8 times 2 plus 6, which resolves to 8 divided by 8 plus 8 equals x, which gives us our 16 again. And now critically, when we put it after the divisor, 8 times 8 divided by 2 parentheses 1 plus 3 end parentheses plus 8 will become 8 times 8 divided by parentheses 2 plus 6 end parentheses, because we're still doing that quantity. We've done the multiplication. We haven't done the addition yet, plus 8. That 2 plus 6 becomes another 8, and we get 8 times 8 divided by 8 plus 8 equals x, which gives us our 16. So if we do distribution first every single time, we get the same answer of 16 every single time. Distribution just plain works. And also, because the law of distribution says that you can distribute multiplication over addition in either order, that is, either doing multiplication first like I showed here, or doing addition first and then your multiplication, you will get the same answer. It doesn't matter the order you do those steps in either. In other words, as long as you're doing both the addition and the multiplication in the same distributive action, 2 parentheses 1 plus 3 end parentheses can turn into either 2 plus 6 or 2 times 4, and both will give you 8 as your final result for that action of distribution. So think about this. And I mean that. Think about this. Don't just adhere to a rule because it was taught to you some way. Actually think for a minute. If doing distribution gave us some weird errors that we had to account for by tweaking an equation or adding parentheses we normally don't need, like PEMDAS does with division, then it would be a matter of opinion as to whether PEMDAS or the distributive method should be preferred. But given the fact that the distributive method remains completely consistent throughout and does not lead to those errors, you have to conclude that the distributive method is objectively superior. In fact, I've put up several videos on this topic already. For those math whizzes out there who are saying, I need to retake first grade mathematics, give me your video showing where doing the distributive method of calculation leads to a contradiction. I've shown you plenty of times that PEMDAS fails where it runs into division and how it consequently breaks such important things as factoring, for example. Show me one place where you will run into those types of problems following the distributive method of solving equations, and I will immediately do a mea culpa video crediting you with the discovery of a lifetime. But you're not going to be able to do that because the distributive method is consistent and mathematics are built off of it, not PEMDAS. In any case, whether you agree or disagree with me in the end, I do genuinely hope you have a wonderful day. And peace out for now.